Welcome back, everybody. Today we'll be solving systems of equations using linear combination. Another way to think of it is simply adding the equations together, and by doing so we hope that we get a variable to eliminate, and then we'll use substitution the rest of the way. So let's look at this first one. Notice we have D's and E's instead of X's and Y's. Notice the D's are lined up, E's equal signs, and the numbers in the equations. So we're going to treat this just like a giant addition problem. 3D plus D gives us 4D. The E's cancel out because negative E and positive E will equal 0 when added together. 7 and 5 make 12. Now we have a simplified equation with just one variable. 4D equals 12. We can divide both sides by 4 and get D to be 3. We now have half of the answer figured out. Let's go back and revisit the second equation. D plus E equals 3. I'm going to take what D equals 3 and substitute it in for D in the second equation. Now I could have used the first equation, no problem there. I just picked the one that looks like it's a little bit easier to deal with. So I'm going to put a 3 in for D. I'll rewrite the rest of it. And looks like a typo there. I meant to type 5. Rewriting the original equation. Alright, and we solve for E. We'll just subtract 3 from both sides. And E equals 2. Write it as coordinate form, D comma E as opposed to X comma Y. 3 comma 2 is our final answer for this system. You could of course check yourself graphing these on Desmos using X's and Y's instead of D's and E's, but this is how to do it using linear combinations. Let's look at it again here. We have another set of equations. We have 2x plus y equals 15, x minus y equals 3. Let's do what we did before and add these together. 2x and 1x make 3x. The y's cancel out, and 15 and 3 make 18. Divide by 3 on both sides, and we can find quickly that x equals 6. Halfway done with the solution. Let's take that 6 and we'll substitute it in for x up here. And then let's rewrite these equations. We got 6 minus y equals 3, substituting the 6 in for x. 6 minus what number is 3? That number is 3. So our solution here, 6 comma 3, if we were to graph these two, they would intersect at this point. Alright, now this next one we have to do a little bit of manipulation. Notice if we were to add these together right now, nothing would cancel out. We would have 9x, 2y, and 6. We need one of the variables to cancel out. It would help us if one of the y's were a negative, and we can do that by multiplying everything in the second equation by a -1. So what I want to do now is rewrite the first equation, untouched, unaltered. And then if I multiply everything in the second equation by a -1, watch what happens. We get a -4x, we get a -y, and we get a -4. Now we're okay multiplying by -1 because rule in algebra, what you do to one side of an equation, do to the other. 5x minus 4x, 1x. Y's cancel out, 2 minus 4 is -2. We instantly have an answer to one of the variables, x equals -2. We can take x equals -2 and let's substitute it into the very first equation for x. We'll show that work right here. 5x plus y equals 2. X was right here. I'm not going to use x. I'm now going to substitute in the value -2. 5 times -2 is -10. Negative 10 plus y equals 2. We'll add 10 to both sides. And y equals 12. We now can write it as coordinate form. Negative 2 comma 12, the solution to the system. A reminder, if you were to graph the system on Desmos or another graphing tool, they would intersect at the point negative 2, 12. All right, another example. We have a little bit more work to do. Notice the system, 4x minus 3y equals 15. 2x plus 2y equals 4. If we were to add these together, we get 6x and negative 1y and an equals 19. Nothing cancels out. Look at the y's for a minute. We could find a common multiple of 2 and 3, which would be 6. Multiply the first equation by 2, second equation by 3, and we could get the y's to eliminate. It's a little bit easier if we multiply the second equation by a negative 2. What that does is turn the 2x into a negative 4x, thereby canceling out the x's. So we're going to do that instead. Alright, rewriting the first equation, we have 4x minus 3y equals 15. Nothing's altered there. And 2x plus 2y equals 4. Everything multiplied by a negative 2, negative 4x, negative 4y, negative 8. Add these two together, the x's cancel out, we get negative 7y equals 7, because 15 minus 8 is 7. We'll divide both sides by negative 7, and we'll get y equals negative 1. I'm going to take y equals negative 1, and substitute it in for y in the first equation, second equation. Let's rewrite it here, 2x plus 2y equals 4. Here's the slot where y would go. However, I'm not using y. We're going to use negative 1. We found that from our work before. 2x minus 2 equals 4. 2 times negative 1 gives us negative 2. Add 2 to both sides. 2x equals 6 divided by 2. 6 divided by 2 is 3. We now have the solution to the system, 3 comma negative 1. There we go. Let's look at one more. This one, we have, not only does nothing really cancel out, 3x minus 1 half y, negative 7 halves, x plus 2y equals 1. We have some fractions in here making it a little bit more difficult. We could try to eliminate the x's by multiplying the bottom equation by negative 3. However, manipulating the y's may, if we're lucky, get rid of the fractions as well. So I have a 2y, positive 2y. I want negative 1 half y to turn into a negative 2y. And I can do that by multiplying everything by a 4. So watch what happens. Rewriting the first equation, everything times 4, we get a 12x, negative 2y, and a negative 14. Negative 7 halves times 4, negative 14. Here's the second equation, x plus 2y equals 1. And we're now ready to add the equations together, 12x and 1x, 13x. Y's cancel out, negative 14 plus 1, negative 13. Dividing by 13 on both sides, we see we get a negative 1 for x. We're going to take negative 1, substitute in for x in the first equation, and let's write that. Let's work on that off to the side here. The plus 2y equals 1. Here we have x right here, but we are going to substitute in negative 1. To solve for y, let's add 1 to both sides. 2y then equals 2. Divide by 2 on both sides, and we see that y equals 1, giving us a solution to this system, negative 1 comma 1. x is -1, y is 1. Thank you for watching. Hope this helps.